Okay. So what was the question? We have to find total cost. Okay, so how to find total cost of energy consumption? So for fan, so number of fan, if we are finding a fan, then rated means it will be power, it will be the,
Sir, are we doing working energy?
yeah. Okay, so what next chapter shall we start? Because we have finished everything in this work and energy, I guess so. Is there anything left for you?
No, sir, it was still power only.
Right, okay. So what should be our next chapter?
Sir, I'm having test from 21st. So can we do gravitation?
Gravitation, okay. What about others?
Yes, sir,
So we'll do
gravitation.
gravitation.
Do you have that for your syllabus, your exam?
Yeah.
Yeah, sir.
Okay. Yeah, then we can start gravitation also. So total number of fan, rating, hours of usage, cost per unit. So generally rating of your fan will be 500 watt. So convert this 500 into kilowatt, that is divided by 1000. Keep it like that. And remaining number of fan you have in your house into hours of usage into cost. Generally it will be 3.15 rupees per unit. So multiply with that. Come on. Tell me this answer.
Sir, why 500 by 1000? I didn't understand.
Because we are converting watt to kilowatt. Because unit is kilowatt hour. So this will give you hours, total hours. This is for 1 day. This is cost for 1 day. 1 day. Okay, this will give you kilowatt hour for a day.
Yes, sir.
Are you all able to see my screen, right? Is my screen froze? Or it's like visible properly? Is my screen froze or what? Yeah. Now is visible?
Yes, sir.
Yeah, sir, it's visible.
Okay. Okay, try this.
Sir, I got 94.5.
94.5. How many fans you added?
Sir, 5.
A fan. Okay.
Sir, I got 785.5.
725. How many fan you added?
5 fans.
You also have 5 fans, still not same.
5 fans and 10 hour of usage.
Okay, 10 hours of usage. And for you, how many hours of usage?
Sir, 12.
12 hours. Okay, someone is texting. Okay, no problem. So, done everyone? Oh, take care, man. So it depends how many numbers of, like suppose 5, 10 hours of usage and multiply all those things. Nothing big here.
Yes, sir.
This 5 5s are 25 into 3.5. Sorry, 3.15 will give you total cost for 1 day. So how much it is? 25 into 3.15. So you're paying 78 rupees for a day if you're using 10 hours. Am I audible? Excuse me. Yeah.
Yes, sir, you're audible.
Okay. Fine. Okay. This is for 1 day. If I ask you to find, if I ask you to generate a bill for a fan, this 5 fan, like which month is going on? Fab. So calculate for Fab month. So what you will do? This is
Into
for
28.
exactly. This is for per day and multiply by 28. It will give you for 28 days. 78.75 per day into 28 days will give you total cost of 5 fans for working 10 hours per day for 28 days. So how much is this? Around 2200. How much? 2200 and something. 7 for the 14. Yeah, it should be more than 2000. How much is that?
Sir, I got 2,646.
Okay, 2646. Fine. Okay, did you use same values or you used your values?
Sir, my values.
Okay. So what are your values? What is the charge for a day? Sorry, cost for a day?
94.5.
Oh, 94.5. for 12 hours of usage, right? You use, that's right. Okay. So if I multiply this one, 78.75 into 28, how much I'll get? Plus, cost. Oh, it's too costly. 2000 we are paying just for fan for working for 10 hours per day. 10 hours per day. What is for per fan? Okay. So is there anyone having doubt for this question, this type of question? Do anyone having doubt? Or shall we start next
No,
step?
sir.
No doubt.
Okay, so many have suggested to start like a gravitation. Shall we do that?
Yeah.
Yes, sir.
Everyone is having that same gravitation as a final exam chapter.
Yeah, sir.
Is there anyone who is not having, can say or say, either tell me or raise your hand or whatever it is? No one, right? Is there anyone who's not having this gravitation as a final exam chapter?
No one, I think so.
Okay, then. Then let me create one more. Gravitation. Let's start gravitation. So what do you mean by gravitation? Yeah, what do you mean by gravitation? What is gravity, by the way?
When two bodies are attracted to each other.
Yeah, that's gravity. Okay, gravitation force. Attraction. Gravitation in other sense, we can say attraction. Okay. So, like our Earth is, and this is our radius, and this is atmosphere or orbit. So our moon or satellite, let's start with the satellite. Yeah, somebody saying I'm having gravitation in form of final test. Okay, yeah, great. So if I take this as a radius, okay, then this is moving around orbit. And the force which is acting towards this one, which is holding it. What are the forces here? Which is holding this satellite?
So the gravitational force.
Gravitational force, yes. But still it is moving in its orbit, which is centripetal force also. Now, what is centripetal force?
Object is attracted to the center of the
Exactly.
object.
Yeah. Centripetal force. Attracted towards the center of that. Okay. In short, centripetal force we can say a force which is acted upon object which keeps moving in circular path. Right? A force, we can say force is acting, which force is acting? Centripetal force. Centripetal force acts upon a object which is in this circular path, this moving in circular path. Moving in a circular path. Are you all there?
Yes, sir. Yes, sir.
Okay. Now, can you give me one example for this one, centripetal force? One example I gave, satellite. Okay. What about you? What about you? You can tell me one example. Yes, come on, tell me one example for that.
So when we rotate an object which is tied to a string,
Yes. Correct. Very good. One more example from someone else. Vivek.
Sir, I'm thinking.
Acha, thinking. Okay, okay. Okay. Examples are so easy. See, just understand the word. See what I'm saying. What is this like centripetal force? Force like which acts upon an object that keeps moving in a circular path. So there can be so many.
so
examples.
washing machine,
Washing machine, it's keep moving in like for its axis, right? It's moving in about its axis. It's keeping that tie about its axis. Okay.
Sir, like swing.
Swing. Swing will just swing like
maybe
to and
instead of
fro.
swing, merry-go-round.
Yeah,
Yeah,
you
man.
can say that. You can say merry-go-round. Swing will just move to and fro motion, to and fro.
So marble in a glass when you're spinning the marble in the glass.
Yeah, it will try to come to the center, but it's stuck on
Yes, so
border.
like you have to
Border.
keep it from touching the bottom so it'll have centrifugal force.
Exactly. Good, good. And one more, like you are seeing daily, I think so. In the sky, something is moving. What is
The
it?
moon
Exactly.
and
Right. Moon. Moon is rotating around Earth. And it is only possible because centripetal force by our Earth. Okay. So what happened? Like how we came to know about all these forces and all? It was done by Mr. Newton. Right. So you know that story, right? That apple fell on like a head of this Mr. Newton. So he just thought, okay, what, how, and when. So he did some experiment and he got, okay, that is due to gravity. He gave a name, gravitational force. So even like what is universal law of gravitation? What is law of gravitation? Can someone tell me what is gravitation?
it is that every
Yeah.
particle attracts every other particle.
Yes, exactly. Then complete the statement.
It
Sir,
is any particle of matter in the universe attracts any other particle which is inversely proportion based on the square of distance between them.
Yes.
and directly proportional to the masses.
Yeah, their masses. So that is force of gravitation. universal, if I say law of gravitation or universal law, which is we are given alphabet for this one, that is G, capital G, which value, what's the value for this one? You know this G value?
Sir, 6.7 into 10 to the power minus 11 Newton
Exactly.
meter square.
Exactly. 6.67 into 10 to the power minus 11. So this is the universal constant, universal gravitation constant. Instead of law, we can say constant. Why it is called universal constant? Because it's constant throughout the universe. And this is what force is, as she said, force is directly proportional to two masses, product of two masses. What are two masses? Let's assume M1 and M2. M1, M2 masses, and provided by distance between them, square of distance between them. It is inversely proportional to square of distance between them. So combinedly we form as F equals to, F is directly proportional to M1, M2 by D square or R square. Let's take R square for distance. It's not a big deal. Any alphabet we are taking here. It's just notation. Okay. So when we are removing this proportionality, we are introducing this constant. So what will it give? F equals to? What will it give?
Capital G,
Yes.
capital G into M1, M2 by R square.
Yeah. M1, M2 by R square. This is the force due to gravitation. Okay. So as you said, this value G is constant. Okay. How we got this unit? We know the value, this value, and how we got the unit? By this. Just I forgot R. F equals to F R square divided by M1, M2 will give you G. So unit of F is Newton meter square by kilogram square. Will give you unit of G, whose value is 6.673 into 10 to the power minus 11. Now, if you observe, this is 10 to the power minus 11. That means it's smallest force. Gravitation is the force due to gravity is weakest force. That's why this comes under weak force. And what is strongest force then? What is strongest force? Have you studied force and laws of motion? Okay, so what is strongest force? Weak force, I said.
Gravitational force?
No, gravitation is weakest force.
Action?
Okay, what are kinds of force we know? You have studied, right? Little bit, if you remember.
So is it nuclear?
Yes,
Nuclear, sir.
nuclear. But why you're not confident?
I remember it suddenly, sir.
Okay. So nuclear force is strongest force. That's why, like, if you know, like, there are hydrogen bomb, atom bomb, nuclear bomb, all are there. So they are not using so big things. They are just using small amounts. Still, it is producing so big energy. It's releasing so much amount of energy. So nuclear force is the strongest force. Gravitation force is the weakest force. Okay, let's not go there. Okay, fine. Let's come back. So as we were discussing, F equals to G m1 m2 by r square. So unit of G we formed as n m square by kg square. Okay. Yeah. So now tell me, like, why we are studying this, why we need this. Newton gave us, okay, fine, but why we need this? Why do we need to study this gravitation? What is the use of this? Can someone
Because
tell
it
me?
plays an important part in our life.
Okay. Earth's gravity, okay, yes. Any other?
Everything relies on gravity.
Everything, like, give some example, be specific.
Gravity holds us to the ground.
Holds us to the ground, okay. Even
And also the sun's gravity keeps the earth in the orbit.
exactly, that is what I was
So
looking
the
for.
atmosphere layer also is attracted due to gravity.
Exactly. And what about in Earth? Okay, this thing it's holding us fine. What else?
The moon also revolving around the earth.
Yes. So how does it help us? Moon is revolving around Earth. Okay, how does it help us?
How does the moon help us, sir?
Like, it's revolving around Earth. Okay, so like how does it
It
help us?
creates tides
Exactly.
and it powers our hydel power systems.
Exactly. That is what I was looking for. Okay, so as you all said, good. It requires, because it's we have to study about Earth's gravity. We should know about Earth's gravity. Yes. And as you said, like, all planets revolve around sun. And it causes tides. So that helps us for tidal power also. That is why needs to study gravitation. Okay, let's make small note for that. Need for so why do we need that? Okay, you can write in your own words. I'm just writing my points. Earth gravitation force, to study Earth's gravitation force. It makes moon to revolve around Earth. Then it makes what? Planet to revolve around sun. And third one, sun and moon causes what? Tides. Revolving, moon revolving, Earth's gravitation. Any other point? Shall we? It's what else we can add, or everything came? Everything we added. Is any point missing about this? Yeah.
No, sir, I don't think
No,
so.
Nothing. Okay then. Let's move to next thing. Yeah, next topic our is free fall. So what is free fall?
Sir, whenever an object falls towards the earth under this force alone, like um, when the objects are falling towards the earth's surface, then we can say it as free fall.
Okay, it is falling, but see, you said like towards the Earth's surface. When an object is falling towards the Earth's surface, we can say free fall. But okay, I'm throwing something from the top of the building. Is it a free fall?
If you throw it without any force, I think it's a free fall.
Exactly. That is what I was looking for. So without any external force, your answers, both answers are correct. Just add that without any external force. Clear?
Yes.
Okay. So when objects falls to, like, I'll say same answer which you said. Just I'll add one more thing. That's it. When an object falls towards the Earth's surface without any external force, only it's falling due to what? Acceleration due to gravity. Okay, so let me write here then, same point. When a body falls freely without external force, only falling due to gravitational force. Due to gravitation force. That is free fall. Now, acceleration due to gravity. Now, what is acceleration due to gravity? Can you give me small like a definition or some statement about that? Yes? Someone?
Sir, acceleration due to gravity, right?
Yeah.
It's when you throw a ball up into the air from ground. It goes with a certain speed up, and it doesn't go in motion again. When it's coming down, it picks up speed. That speed is acceleration due to gravity.
Okay.
So could I say something else?
Yeah, sure.
When a free-falling object has an acceleration of 9.8 meter per second downward, it's called acceleration due to gravity.
Okay. That is also good. Yes, someone else?
Sir, when a freely falling body gets accelerated due to the gravitational force, we as the acceleration due to gravity.
Okay. Yes. Very good. Anyone else? Bhumika? Pulastya?
Same answer.
Same answer? Even yours? Okay. So Yukta, you want to add something? No? Okay. Okay, then let's combine everyone's answer. We can say like as we wrote above. Same thing, we can just add a little bit more. That's it. Well, when object what falls towards the earth for Earth's gravity. Let's write for Earth's gravity. Object falls towards Earth. So we have what? Acceleration. So there is an acceleration. There is an acceleration which is just due to gravity, not external. Acceleration with movement of object. That acceleration is called acceleration due to gravity. So what is the value for Earth? Standard value?
So the value of acceleration due to gravity.
Yeah.
So 9.8.
Yeah, 9.8 is the standard value. Unit? It is
Meter per
denoted
second.
by, yes, it's denoted by G, unit, meter per second square, because it's acceleration. So acceleration will be meter per second square. So if you get confused with this unit, so what do you do? Like remember the formulas, what we wrote? A equals to V minus U by T, right? Change in velocity by time. Acceleration is rate of change of velocity by time. So velocity is meter per second divided by second. So meter per second square. So the value, G value is 9.8 meter per second square. So what's the force formula for this one? F equals to ma. It will be for force due to gravity. It will turn to F equals to m.
G.
Exactly. mg. I think someone is facing internet issue. Okay. Now let's find out relation between the small g and capital G. So for that, what we'll do, we'll take a mass of Earth and object. So this is Earth, mass of Earth and object on the Earth. Earth, object. So force equals to G m by radius of Earth is capital R square. So distance between them is capital R square. So here we wrote F equals to mg. So let's combine this. Mg equals to G m capital M by R square. So G equals to G of R square. Now we got this formula. What does it mean? This G is not depending on mass of the object. It is just depend on mass of the object which is providing gravitation. In short, for us, it is Earth. Can you see this? So just don't learn the formula, understand the formula. This formula says G is depending on mass of the Earth, not depending on mass of us or any other object. So therefore, G will be constant for whatever object it's falling from top, it will be same. It is just depending on mass of Earth as well as radius. Because our G is constant, capital G is constant. So it is just depending on Mass of Earth and radius of Earth. Or not radius of Earth, radius or distance between them. Then them means us, like object and Earth. Is that clear?
Yes, sir.
Okay. So we got relation as G m by r square. Now, will if I ask you a question like G, just now I said G will be constant, right? 9.8 small g. So will it be actually constant throughout Earth? Can you tell me? Will it be actually constant throughout the Earth? 9.8? Yes or no? What do you think?
Sir, it will be.
It will be, it's okay, right or wrong, doesn't matter.
Most of the places.
Okay, so you think it will be constant, right? Yeah, because you haven't learned more about this because it will be in 11th standard, but this G is not actually constant, it varies. But for us, it is not that much difference. It's very, very small. So we are assuming, okay, 9.8, fine, fixed value. 9.81, 9.07, 9 point, like it varies like that. 9.810, 9.801. So it varies like 0.1 point, just 0.1, 0.2, this much it varies. So it won't make much difference. But actually, if we see that, what does this formula, where is the formula? Oh, sorry, X unit. Why it's not scrolling up? So if you see this unit, observe this unit, what it says, meter per second square. What do you mean by
It's
one?
acceleration, every meter per second.
Yes. So it means, yes, exactly. So every meter, it adds 1 meter per second to every second. In every second, it's adding 1. It's actually so high if you observe this. That's why while free fall, some space shoot and they will burn up due to high friction. Right. Okay. Even the reason behind all those things, that is because Earth is not exactly circle, right? It's not a sphere. What is the shape of Earth then? What is shape of Earth?
Just fair.
No, it's not exactly sphere. At poles, it is like flattened. And at equator, if we draw equator line, it will be a little bit like bulgy. So it is like, it shows as ellipse. It looks like ellipse. So that is the reason G value will be varying from pole to equator.
Okay, sir.
Because G is inversely proportional to R square. This is the reason. So what do you think at center? It will be maximum or it will be minimum? Yeah. It will be minimum or it will be maximum at the center of the Earth or core? What do you think? Come on, tell me answer. Think and answer. The center of Earth, will it be maximum or it will be minimum?
Sir, it will be minimum.
G value will be minimum.
Minimum, I
Yeah.
think so.
Okay. Think again. See, if this decrease, what is meaning of this radius? From the center, I'm placing object at center and this object at somewhere else. This radius. So if this radius decrease, I'm bringing this object to the center of the earth. First case, it was here. Let's take case A. This is case B. Okay. So whose distance is more, A or B?
The A.
A is
A.
distance more. So as this increase, inversely proportional means this also decrease. So if it is decreasing, that means G will be max, right?
Yes, sir.
Yeah.
It should be max. What do you think then?
Maximum.
Maximum,
Maximum.
or it might be zero also. Why?
Sir, how?
It might be zero also. If I am exactly at the center, then there is no distance. That means R value itself is zero. That means G will be zero.
Yeah.
Sir, doesn't that mean there's no gravity?
Exactly.
But
But it is logically it is there, right?
yes.
Right. Okay. So we conclude that what G depends on radius as well as mass of the earth. But mass of earth is constant, so it mostly depends on distance from the object or from the center. From center, how much far it is. Okay. So will you try one question? Do we have time? Yes, we have. Okay. So I'm not writing full question, I'm just writing given terms. Mass of earth is given as 6 into 10 to the power 24 kilogram. Radius of earth is given as 6400. Ten to the power 6 meters. Then calculate G for earth. Tell me 3 digits. After decimal, give me 3 digits. Okay, just let me connect power supply. Till then you calculate, I'll just connect my charger. Yeah, I'm back. So what's the answer? 9 point what? How much?
Sir, is it 9.8?
No, give me 3 decimals.
9.806.
806.
Yes, sir.
Mhm. Any other option? Anyone got 9.807?
So one small doubt.
Yeah.
When calculating, we should use 9.8 unless they say we have to use 10, right?
Yeah.
Okay, sir.
So G m by r square. 6.67 into 10 to power minus 11 into 6 to 10 to power 24 divided by 6.4 into 10 to power 6. Okay, into 2 square. Yes? Answer please.
Yes, sir. 9.806.
Meter per second square. There's no like no one got 9.807.
No, sir.
Okay, then let's fix this. Okay, so if I give you G as 9.806 Newton per kg, is this unit same than this one? Are this both unit correct? This one, okay, we know, fine, meter per second square. Is it Newton per kilogram also is correct? Yeah? No? Is Newton per kilogram correct?
I don't know, sir. May not
No,
be.
I think it's not.
Not correct. Okay, let me prove it as a correct. See, Newton is 1 Newton equals to 1 kilogram meter per second square. So if I want meter per second square, I can send this that side. So 1 Newton by 1 kg equals to 1 meter per second square. Now they both are correct. Right?
Yeah, sir.
Okay. No, I want you to calculate weight of a object on a moon. So just let me write a question here.
Sir, isn't it 1/6 of its weight on the earth?
Exactly. We need to prove it. Let's prove it. As a question will prove it. Okay. So mass on earth is 6 into 10 to power 24. Mass of moon is 7.3 into 10 to power 22. Radius of earth is as usual 6.4 into 10 to power 6 meter. Radius of moon is 7.4 into 10 to power 6 meter. So take this question. What you will do? Weight on the moon. Try this question as a homework. Take it.
Okay.
Have you made a note of this one?
Yes, sir.
Sir, 1 minute.
Yeah. Sure. The next class we'll see mass and weight and remaining topic: force, pressure, thrust, buoyancy, all other things.
Okay, sir.
Okay. Have you taken? Will you try it? Don't forget this time, okay?
Okay, sir.
Yes, sir.
Yes, sir.
Okay. Shall I stop sharing?
Yes.
Yes, sir.
Okay. Okay then. Bye-bye everyone.
Bye, sir. Thank you.
Bye, sir. Thank you, sir.
Bye-bye.